Very rarely do you get the opportunity to kind of literally from the ground up put together a factory whose sole purpose is to go make history and do exciting things for not just NASA, but for America and for the whole world.
We're in the process of getting the factory ready for SLS production. And in that process, there's a series of new tools that we've been installing in the factory.
Now we have not just put in new tooling, there's some legacy tooling that we're using. Most of the external tank buildings are being reused. We have a lot of construction going on for those, getting ready for a rocket that's same diameter but a little bit longer.
Not only are we using the legacy knowledge, the lessons learned, we're also incorporating new technologies.
The tool today is in the vertical friction stir welding center, and its job is to produce the cylinders that make up the parts of the tank that will be stacked.
And that is going to be the tool that joins every panel on every barrel for the rocket.
This device will actually do the weld in a single pass and then also do inspection. So these are the large barrel sections of the core stage that will be the foundation or the beginning rocket that will actually take our crews beyond the moon and really propel us into space.
Here at Marshall, we've designed the interface hardware in between the Orion capsule and that upper stage.
The MSA, I think, is a great example of a couple things. One, it's actually a piece of hardware that we're flying on an early test, but we're also going to fly for the long term. And so this is the same design that we'll use when Orion's on the SLS and we're actually flying people.
Today we've been taking the two unique pieces of hardware that are supposed to have a common interface, basically lowering them together, bolting and making sure that they fit.
Well, we're going to test a lot of the key systems on Orion and also for SLS with the upper stage of the MSA that are going to be used when we fly people into deep space.
Most recently, we've been involved with NASA with the SLS development using our unique forming technology along with our other core processes in terms of machining, welding, heat treating, and inspection technologies. Really is a one-stop shop is what way you would describe it.
Right behind me you have the first weld development cap, or I think you call it the weld confidence cap. The production order will start deliveries in 2014. Spincraft also builds the domes for the upper stage Delta IV vehicle, which will be used for the EFT-1 flight, as well as the first two production flights of the SLS program.
For the SLS PDR, our primary role was the overall communication and outreach support that we provide back to Todd May's office for SLS. We provide all of the communication support for that particular team, that program and project.
Well, it's a preliminary design review, and primarily it's a technical review to make sure that the design is acceptable and at the appropriate level of maturity.
There's a lot of discussions, there's a lot of meetings across the board from technical, cost, schedule, performance data, safety, human factors.
It's like a health check on the program. Those of us that are working on the program, we've got our head down, we're doing our pieces. And sometimes when you're working real close to things, you don't necessarily see everything.
So there's so many moving parts and so many things going on at the agency, as well as the center, that to show people that we are moving in the right direction, to pull together a complete story of where we are as a program.
Watching at it from a higher level headquarters viewpoint, it's just gratifying to see the accomplishments that the teams have made and continue to make every day.
For CT2, we're doing modifications not only to make it last another 20 years, but also to uprate the load capacity. The main project we're working on right now is the roller replacement project, which is the roller assembly. It's actually the rollers, the shafts, the bearings that support the crawler. Actually, if you go there, you'll see trucks A and C jacked up and on cribbing. And that's the first time in the career of the crawler it's ever actually been jacked off the ground. So that the guys have easy access to the roller assemblies. And they're in the process now of removing the old rollers, old shafts and old parts. Once they've done the line boring, that's when they'll start assembling the new rollers and the new shafts and the new bearings and the new sleeves and new adapters and new plates. So there's quite a bit of work, and that work will go well from August through October. So there's going to be a lot of trucks delivering a lot of steel here at Kennedy.
We started actually the new design for flame deflector as well as refurbishment of the flame trench, and that's because of the new requirements for SLS and commercial vehicles. We've started the demolition of the flame deflector. We've got concerns of, due to age and the debonding of the flame trench structure, this would possibly be a safety hazard for our new program. And that's why we had to go in and do a new design and refurbish this flame deflector and flame trench.
These pieces here, they're not just one program, it's not just one mission, it's part of a capability that will enable this country to be a leader in space, to continue to take people from the Earth well beyond low Earth orbit out into deep space. And this is the hardware that will do that over multiple decades in the future.
So the work that's been accomplished so far is primarily structural type work, right? It's a lot of drilling, a lot of secondary structure installation, mechanical structures, the support structures. The next step is starting to install the subsystems. When we actually perform the welding on tubes for propulsion and the environmental controls and life support systems, those have to be at a higher level of cleanliness. When you look at the facility, there are these very large walls that are on the perimeter of the structure itself, and those are called HEPA filter walls. We can perform clean room work for the tubing concurrently while on the outside doing more standard clean room. So our goal is next summer sometime to turn the vehicle over, early summer, over to the Ground Operations Organization so they can start their processing.
Well, the service module is attached below the crew module, and it has the prop tanks and the engine, radiators, solar panels. The service module all came in pieces. There's 49 composite panels on the SM. The actual structure itself is aluminum. That's the core skeleton where these composite panels were attached to. After the CM releases and the CM returns to Earth, the SM will just burn up with the upper stage of the Delta IV.
We performed two primary tests so far. The proof pressure test, which is just the pressure vessel, and that is put into the proof pressure cell. It's pressurized and a relatively high pressure. We're testing how well the vehicle was built. And then the follow-on test is the static loads test, where the vehicle goes through 8 different loads test cases. And so the vehicle is put under pressure, it's put under tension, it's put under compression. The whole intent is to simulate similar conditions that the vehicle would experience, say in flight, in launch, and also in landing and recovery.
We usually get the abort motor first, and for this mission the abort motor is inert, being a nominal flight.
We're going to have instrumentation on it to again understand more about the loads and environments that we expect to see in flight, but it will be an inert propellant that's cast into the motor.
This time we got the jettison motor next, and that's the only live component of this vehicle. We do a nominal jettison, the jettison motor fires, the last separates from the CM, and the CM continues on its mission.
You know, one of the challenges of any new system is understanding the loads as you ascend up through the atmosphere and the dynamics, the acoustics, and we'll be able to gather a lot of that information.
The back shell, it looks though it looks the same as what we flew on shuttle. It is different. We kind of took the best aspects and put them together to meet Lockheed Martin's requirements for the Orion capsule. Two major things we're trying to accomplish here. One of them is to prevent micrometeorite damage when we're on orbit for long duration. The other, of course, is the reentry aspect. The skin that you see on the capsule, what you would see on orbit, sits on top of a composite substrate, what we call the back shell panel, that when combined together gives you the complete back shell. There's some sections that have some very complex geometry. So what we're going to do for the first time is take a substrate that's built by Lockheed Martin and put it together with the tiles that are manufactured by Jacobs and validate the fit up. Like any test vehicle, you're heavily instrumented. We're going to come back with a tremendous amount of data on how the system performed.
This first flight test of Orion is really to understand how the heat shield performs, and that heat shield's going to final manufacturing at Textron. Textron's had a long association with NASA and working in the space area for space protection.
The technology today has advanced tremendously. Our manufacturing technology has advanced, but ironically, we're still using a material that has proven itself for the last 40 years.
AVCOAT is a very efficient ablator, and as an ablator, what it does, it allows us to protect the capsule from the high heating that occurs during re-entry.
There is no material, non-ablator material, that can handle that kind of heat. You have to shed away the heat. Basically what you're doing is you peel off the layers of the heat shield, you're taking heat with it.
When we apply AVCOAT to the heat shield, we bond the honeycomb onto the carrier structure, and then we inject the AVCOAT ablative material into the cells. The honeycomb acts as a crack arrestor and gives it rigidity and strength as a whole.
We know we're on the critical path for the Orion program, and so our employees are literally working all hours, all days of the week to make sure that we hit our schedule. We know there'll be more heat shields coming, and we're very excited about that. Our job is to make sure they're perfect.
The development programs I find just awesome, because this is where you're coming up with the new ideas, you're creating the new vehicles, you're pushing the boundaries in essence.
You can feel that we're going to go do this. The hardware is starting to come. The Orion hardware is getting ready for its first flight test down at the Kennedy Space Center.
The excitement is here. We are really ready to get going. So we are far from being out of space. We are really getting ready to go into space.
That's so rewarding to see our focus into what's next, because this really is our future.
I know the day that we fly this thing, there are going to be thousands of people that are going to be excited, that are working on this, and the NASA workforce and the contractor workforce. We're going to be proud of the work that this team has done, and I think we're going to be proud of our country too. It's going to be a pretty exciting time.
I'm ready to build a rocket, and we are ready, and we want to build it on time.